Yes, up next, the definition of function. Function is corresponding between the first set we call domain and the second we call range. So that each element of domain corresponds to exactly one element of the range. If we say like this, maybe it's difficult for understand. If I show you some example, maybe it's very easy. F support F A B C D. This is we call A is subset of relation of R. Support this relation is have function, then A is C and B is D. B is D. This is relation we call function. I show you example. Support F is 1, 2 or 2, 4 or 3, 7 like this. You check. The first in order pair 1, 2, 3, they are different, and the second in order pair 2, 4, 7. This is different. This different. This is one of example in function. Suppose I show you design. Yes, good equipment. F is 2, 4, 2, 5. How about this relation? Support relation. How about this relation? Is function or not? Not function. Why? Because the front or the first element is equal, but the front or the back or the second is different. It's conflicts from the definition of function. So this is relation or it's not function. But support R is 2, 4 3, 4. How about the relation function or not? Yes. Why? Because the first is different. The second or the back is different or the same. It does not matter because this one is f or function. Maybe if you want to check which one function, the first, if the relation in tabular form, in this tabular form means we can show every element inside the set. We can check this very clearly if the front is the same, so the back is the same too. And the second, if the relation is set binary notation, support sets of x, y, such that belong to I cos I. Y is x squared. Y is x squared. How we can check this relation function? How? First, you sketch graph. How do you know this? What is the name of relation y is x squared? Who can answer? What's the name of y is x squared? Yes, very good student. Y is x squared. We call parabola. Upward or downward? Upward. Is we know about this name. And we can sketch this y-axis, this is x-axis. Then we sketch graph. X is 0. How about y? If x is 0, how about y? 0, 2. X is 1, y is 1. Very good student. X is negative 1, y is 1. Very good. After that we can sketch because we know about this parabolized form. After that, the third, after we sketch the graph, how we can take a look. If the equations towards graph checked by draw the line parallel with y-axis, we can check this is function or not by draw the line parallel to y-axis. Parallel is mean like this. Parallel y-axis. If the line cut one point on the graph, this is one point only. Every position of x, suppose here, one point, everywhere is have cut on the y is expressed one point only. For this, we can decide about this is its function, is one point only when we cut off the graph. Next, I show more example. Support is I show example. I choose question 11. Question 11. Sets of x, y belong to R cos R, such as y is 3x minus 5. What is the name of this? What is the name of this? What? Straight line, or we call linear. We call linear equation. Very good. I show you in question 11. Y is 3x minus 5. How we can sketch? It's easy. This is y, this is x axis. We start if x is 0. If x is 0, how about y? Y is very good. 1, 2, 3, 4, 5. If x is 2, one, very good. After that, we can draw or make the line because we knew before this is the line. After we get the graph, we can check this is function of by draw the parallel line with y-axis. Cutting here is one point only everywhere. If every position of x. This is we can decide this is function.
I don't understand number 28.
28. Wait. Before the question 28. 28. Oh, okay. Take a look. Question 28. Sets of always x, y belong to R cos R. Such as 4x squared minus 9y squared plus 6y minus 1 is 0. Sorry, what's here? Quite cool. For this question, the name of this relation, who know about this name? If you learn after this section, we call coordinate section, we know the name of this relation. 28. Relation we call hyperbola. Hyperbola. If I show you full because it's not quite clear? Yes. About hyperbola, I tell you first. Y x 4x squared minus 9y squared plus 6y minus 1 is 0. Usually, if we know about the function or hyperbola, maybe it's like this. It have the pair of parabola. Parabola like this, we call hyperbola. And for this question, they start by x first, followed by y. Therefore, it have the figure like this. After, we can check this is function or relation only by drawing the line parallel with y-axis. How many points they come to? Very good, student. So this is function or not? No, not function, but relation only.